Welcome to All This Math. This is Professor Parker, and today I want to do some work with right triangles. All right. Now, typically when we see a right triangle and we're trying to solve for the missing sides of a right triangle, we might use some trigonometric ratios, some trigonometric relationships, or we might use what is commonly referred to as the Pythagorean theorem. But we can't use the Pythagorean theorem because we're missing two sides, right? So this is a right triangle, and the side across from the right angle, this is the right angle, and the side across from it right here, this will be the hypotenuse, right? Which is a length of 10 units. And then we have two legs. These other two sides are two legs. So we're missing too much information. So that's basically why we can't use the Pythagorean theorem, right? So we could get into some, like I said, some trig ratios. We could do that to find out some of this information. But there's something else we could do that I want to talk about today. So as you see, I have here in green, right? These are some formulas, right? And these are formulas that you use when we deal with what's called a special right triangle. Now, there are two types of special right triangles, all right? So one type of special right triangle is the one that we're about to deal with right now. And then there's another type of special right triangle that we're not dealing with right now. And that special right triangle that we're not dealing with has measurements of its angles of 45 degrees, 45 degrees, and 90 degrees. So that's commonly referred to as the 45, 45, 90 right triangle. All right. So that's not what we're dealing with right now. Right now, we're dealing with the 30, 60, 90 right triangle. Now, you might be wondering, well, if you look at this picture of this right triangle, you know that that's 90 degrees, and you see that that's labeled 60. So you might be saying, well, how do I know that that's a 30, 60, 90? Well, the way you know that it's a 30, 60, 90 right triangle, meaning that one angle is 30 degrees, one angle is 60 degrees, one angle is 90 degrees, is because all three angles in any triangle, it don't matter if it's a right triangle, it don't matter if it's isosceles, scalene, equilateral, whatever, all three angles in any triangle, if it actually is a triangle, must add up to 180 degrees. No matter what type of triangle, no matter what the sides look like, no matter what the legs look like, no matter what the angles look like, they must all add up to 180. That's the common denominator among all triangles. All three angles in any triangle must add up to 180 degrees. Now, if I know that this is 90, because this little box is drawn in the corner, so that's got to be 90. That's a right angle. And I know that this is labeled as 60. That's 90 and 60 right there. You put 90 and 60 together, you got 150, right? So if all three angles have to add up to 180, I got a 30-degree difference between 150 and 180. So that means that this angle up here must be 30 degrees. All right? It must be. Now, once I know that that's 30, now I say, okay, well, this is a special right triangle, right? It's a case of a special right triangle which has an angle measurement or angle measurements of 30, 60, and 90. Because that's my 30-degree angle, that's my 60-degree angle, that's my 90-degree angle. Now, direct your attention down to this green box right here. These are the formulas for if you want to find the hypotenuse, HYP, I abbreviated hypotenuse. If you want to find the hypotenuse and you're given other information, if you want to find the LL, now LL, I use the abbreviation LL or the acronym LL to represent the long leg. Because remember, it's a right triangle, right? It's a right triangle. You got two legs and a hypotenuse. It's three sides, but within those three sides, you have two legs and a hypotenuse. So these are my two hypotenuse formulas, right? LL stands for long leg because you got a long leg and a short leg. The longer leg is always across from the 60-degree angle. The shorter leg is always across from the 30-degree angle. Think about it. Smaller angle, shorter leg. Bigger angle, longer leg. So the shorter leg is across from the smaller angle. The longer leg is across from the bigger angle. And that's in terms of the 60 and the 30, comparing those. We already know that this is 90, and that's the biggest angle in the whole triangle. But the 90 is across from the hypotenuse. So the hypotenuse is something separate, right? So, and then the SL represents short leg, right? So SL is short leg, LL is long leg, HYP is abbreviation for hypotenuse. And basically, if you can memorize these six formulas, and maybe, you might not even want to necessarily, memorize them. I mean, I recommend you memorize them. But what I'm saying is if you don't memorize them, you can still have success at these types of problems. because you can derive and figure out other information in other ways, right? And some of these formulas are like, they're all derived from each other, right? So, but what I want to do is I want to use these formulas in order to figure out what X is and what Y is, okay? So now, if I want to know what X is, I look into my list of formulas and I say, okay, first off, is X my hypotenuse, my long leg, or my short leg? I know it's not the hypotenuse because it's not across from the right angle. It's adjacent to the right angle. All right. Now, out of the legs, is it the longer leg or the shorter leg? Which one is it? That's another question I have. Is it the longer leg or the shorter leg? This is the longer leg, right? Not because it looks like it, because this might not be drawn to scale, but you always judge it based on what angle it's across from. So if this is across from the 60-degree angle, then it's the longer leg. So put that in your notes. The longer leg is always across from the 60-degree angle, no matter what. The longer leg is always across from the 60-degree angle. The short leg is always across from the 30-degree angle, okay? So I go to my long leg formulas, all right? Now I look, okay, which one of these formulas do I want to use? Do I want to use the one with the hypotenuse in it? Yes, I do, because I know what the hypotenuse is, right? I can't use the one with the short leg in it because I don't know what the short leg is. The short leg is a variable, just like the long leg is. All right. So now I'm going to get to work. I'm going to use this formula right here. And I'm going to say, I'm going to replace LL with the variable X. So I'm going to say X equals root 3 over 2 times the hypotenuse. Now the hypotenuse, I know the measurement of the hypotenuse. The hypotenuse is 10, right? So I'm going to replace this abbreviation for hypotenuse with a 10. All right. And now I just got to multiply this number by that number. Now, this might look a little weird because it has a radical sign in the numerator, but we can still rock out with this, right? So I just do 10, put the 10 in front of the radical, 10 root 3 over 2, and then I want to simplify that. So 10 root 3 over 2. Now, I'm not going to do 10 times 3 because the 3 is inside of a radical and the 10 is not. So make sure you don't do that. But what I can do, I can divide 10 by 2. And 2 is a common factor, or 2 is a factor of 10, actually. So I can do 10 divided by 2 and I get 5. So that leaves me with 5 times the square root of 3. So that means that the length of the long leg, which is also X, is 5 times the square root of 3. All right? Now let's figure out what Y is. Y is the short leg. As a matter of fact, I should have labeled it. Boom. X equals LL, Y equals SL, right? Now, so if Y is the short leg, I go down to my 2 short leg formulas, right? Now I go back to the information that I know. Now, I just figured out what the long leg was, but typically, as a habit, when you're solving problems, you want to use information that's given, not information that you derived if you have a choice, right? If you don't have a choice, then you got to use what you got. But I know what the long leg is because I just calculated that, right? So I could theoretically use this formula for the long that includes the long leg in it. But I typically want to use, when using a formula, and I don't know if this is just like something that my teachers in the past taught me, but I think it does make a lot of sense, to use the formula that includes information that was given in the original problem. So originally in the problem, we were given information that the hypotenuse was 10. So let's use the formula that includes the hypotenuse instead of what we just found, because we don't have to use that formula, right? We could, but we don't have to. So now what I'm going to do is I'm going to say, okay, Y is the short leg, so I replace SL with the variable Y. And now I have 1/2 times the hypotenuse. The hypotenuse is 10. So I got 1/2 times 10. And 1/2 times 10 is 5. I mean, I can show you, 1 times 10. Now, here's another thing. I do want to show this point to anybody that's watching, because we have to know how to multiply fractions by whole numbers. I know that's like a blind spot for a lot of people, multiplying fractions by whole numbers, because what a lot of people do is this. They'll do 1/2 times 10, and they'll say it's 10 over 20. And you'll be like, well, how'd you get 10 over 20? Well, see, actually, how'd you get 10 over 20? You get 10 over 20 because what they did was, let me fix this 2. I don't like the way that 2 looks. So what they did was they multiplied 10 by 1 and 10 by 2. That's not how you multiply a fraction by a whole number. That's not how you do that, right? Think of it like this. When you're multiplying, a fraction by a whole number, right? You can represent a whole number as a fraction. All you have to do is write a 1 underneath of it as its denominator. And then you just multiply horizontally, right? So 1 times 10 is 10. Draw your fraction bar. And 2 times 1 is 2. And then you can simplify that. And you do 10 divided by 2, which is 5. So make sure, you know, that's not a blind spot for you any longer. Make sure you understand that when you have to multiply a fraction by a whole number, whether you write it down like I did right here, or whether you just think about it mentally, there's an invisible 1 underneath of that whole number, right? So you only multiply the 1 by the 10. And then the 2 gets multiplied by an invisible 1, which will give you 2 for your denominator. And then you do 10 divided by 2, which is 5. All right? So make sure you're doing that. So that means that my y value is 5. So my short leg is 5. All right? And that's just a little bit, you know, that I wanted to show you on how we deal with special right triangles. And as a matter of fact, what we can do is we can check our work by using this other formula. All right? Because the short leg should also be equal to root 3 over 3 times the long leg. All right? So let's try that just for practice. So we got y equals root 3 over 3 times the long leg. Now we think that the long leg is 5 root 3. So let's see what happens. Let's see if we get the same answer. Let me see something. Let me stay consistent with the formula. So the short leg is equal to root 3 over 3 times the long leg, which is 5 root 3. And so now we're going to do 5. There's a 5 right there. And then root 3 times root 3 is technically root 9, which is over 3. And then the square root of 9 is 3. So that gives us 5 times 3 over 3, which gives us 15 over 3, which also gives us 5. All right? So that's a way to check our work and to verify that our answers are correct. So for our long leg, or for x, we got 5 root 3. And for our short leg, or for y, we got 5. Doing it both ways. All right? So again, that's just a little bit about, you know, how to deal with special right triangles, whether they be a 30-60-90 right triangle or a 45-45-90 right triangle. That's just a little bit on that. All right? Please like the video, subscribe to the page if you haven't already, share the videos. And as always, remember, there's all this math all around you. Peace.